Are we playing now?
Yeah.
Are we a live
Okay.
audience?
So we're looking at 12x cubed plus 144x squared. Okay, so when you first learned about factoring, this is where they started. It's called taking out the greatest monomial. But it really means just factor out a GCF. So we look at the numbers, we say do 12 and 144 have a greatest common factor?
Yes.
What are they?
12.
12. We also have to factor out a variable. It's always going to be the lowest exponent.
X squared.
So x squared. What would we be left with then?
X squared plus 12x.
We'd be left with x
Plus 12.
of x plus 12. Because remember, it's backwards distribution. So you really have to think 12x squared times what would give you 12x cubed? And then 12x squared times what would give you 144x squared? Okay? We look then to make sure we can't factor what's inside those parentheses anymore, can we? No. So we're done. And there's my answer. Okay? All right, let's look at the next one. I made it a little harder, number 2. A cubed plus 2a squared b minus ab squared. So now I've got a trinomial. I have to look at all 3 terms, and I have to see if I can factor out a GCF. Does anyone see a greatest common factor? All right, Ellen. Ellen, it's A. Okay, so we take out an A. What are we left with, Benny? What are we left with?
Oh, my bad. A squared plus A. Oh, wait, no,
Plus 2A.
Yeah, forgive me. 2AB minus B squared.
B squared. Okay, whatever's missing. Okay?
I have a sheet.
Oh, you didn't get one. Okay, did everybody get one? I thought I passed them out.
Are we allowed to write on these?
Yeah, this is yours.
Who wants to wear
This is
this
yours.
now?
CJ does.
Okay.
No, thank you.
Are we ready to move on? Do you guys feel okay about those 2?
Yeah.
Okay, I'm going to skip the 3rd one then. Let's go to the difference of squares.
Double up.
Double up.
This is probably, I got to take the wig off, sorry.
Get
I can't do it, it's too hot.
Too ridiculous.
Scratchy. Get all scratchy.
The difference of squares could quite possibly be the most important factor pattern that you will learn this year and next year and the year after. It will be the factor pattern that you're going to have to recognize on the SAT almost in half the problems. And it's the one that is really where we make mistakes, and it's not that hard. The difference of squares means that you have every single time 2 terms, okay? Both are perfect squares. And what does difference mean?
Opposite.
What?
Subtract.
Subtract. And there's a minus in the middle. Do you guys know what a perfect square is?
64.
64. 9.
144.
144, 36, 25.
Nine.
Is 1 a perfect
400.
square?
Yes.
Yes.
Yes, 1's a perfect square. Is x squared a perfect square?
Yes.
Is y squared a perfect square?
Yeah.
Wait, how is 1 a perfect square?
1
One
times
1
times
times 1 is 1.
Coach Red, I'm taking SATs tomorrow.
Oh, good. Okay. All right.
I was supposed to.
Okay. We're videoing, guys. Stay with me. Let's look at the difference of squares. Before you even start, we always check to see if there's a GCF. Is there a GCF? No. There is not. No GCF. Then I say to myself, is it the difference of squares?
Yeah.
Why?
Because there's a minus, there's 2 terms.
And they're both perfect squares. You do need to check that because I will try to trick you. Because, you know, that's what math teachers do well. All right, so how do we factor it?
No, you can't do it.
No, it's minus.
No, I'm saying
But what
it
if
is a
it's a
plus.
I'm going to explain that. Just relax. The difference of squares is the difference. So we're looking at minus. So how do you factor it? The basics, guys, it's the square root of these numbers. What's the square root of x squared?
X.
X and x. What's the square root of 64?
8.
8 and 8.
Plus
Plus
Plus minus. Do you remember doing that?
Yeah.
Okay, so then let's jump to number 3. All right? Number 3, 4r squared minus 49t squared. I jumped and made it harder right off the bat. Difference of squares. Is it the difference of squares? Is this a perfect square?
Yeah.
Is this a perfect square?
Yeah.
Is that a perfect square?
Yeah.
Is that a perfect square?
Yeah.
Is there a minus in the middle?
Yep.
Whoa, it's the difference of squares. So I take this, it's the square root of all of it. 2 binomials, we should be writing things down. One's plus, one's minus. So what, Dominic, is my first number? First term.
2R.
2r and 2r. And then
7T.
7t and
17.
17. You guys feel good about the difference of squares?
Yeah.
All right, then let's jump to number 5.
Wow.
What does number 5 say?
3x squared minus 75.
3x squared minus 75. What do we always check for? What do we always check for, Will, when we're factoring?
GCF.
A GCF. Is there a GCF? What's the GCF, Avery?
3.
Will, you want to leave? Because it's driving me crazy and I'm videoing. You're ruining the video.
Yeah, bro.
Yeah, bro. All right. My goodness. What's the GCF? 3. We take out the 3. What are we left with?
X.
X squared minus 25. Is that the difference of squares? It sure is. So now we have 3x. Good. X minus 5, x plus 5. Does it matter? Could I say x plus 5, x minus 5?
Yes.
I sure can. So you remember the difference of squares. All right. Let's look at the next section then. The next one are not perfect square trinomials,
Wait,
but...
number 4 isn't a difference.
Yeah, it is.
Oh, it is? There's a GCF of 3 in
It
it.
goes like really far though.
Oh,
Okay.
never mind. Yeah, I got it wrong.
No, because you divided by 4.
Sorry.
83 times
Oh.
4 plus 1.
All right, let's look at some basic factoring trinomials though. Now this is where it starts to get harder. All right, I'm going to show you something that I use when I teach factoring, and it makes everything a lot easier for you. You can always check and you can get them right 100% of the time if you follow this, okay? All right, so we're looking at, and this is an easy one for me to show you an example. X squared plus 7x plus 6. Everybody good there? If you're factoring a trinomial, the first thing that you'll always do is see if there's a greatest common factor. In this case, since this is a 1, there isn't. Okay? So we know that we're going to be factoring it to 2 binomials. All right, when you're factoring, you're always looking for the 2 numbers that multiply to give you that number and add to give you that number. Okay? All right, so we look for the factors of 6. The factors of 6 we know are 1 and 6 and 2 and 3. Okay? And then we say to ourselves, which one of those will add to give me 7? 1 and 6. All right, so we have an x and an x, a 1 and a 6. Since these are both positive, then my terms will both be positive. Now, if you wanted to check your answer, your teacher probably told you when you learned this that you could FOIL this. Because what should happen if you FOIL it?
You get that.
You get that. Do you want to FOIL it every time?
No.
No. So I've been doing this for I don't even know how long. I think, here's the word FOIL. FOIL means first, outer, inner, last, right?
Oh.
Okay. If you got x and x, I hope at this point that you guys can say to yourself x times x in your head is x squared. So do I have to do the f? Does x times x give me x squared?
Yes.
I don't really have to do the f. I can see that. What about the last? 1 and 6. What's 1 times 6?
6.
Do you know that by looking at it?
Yep.
So I don't have to do the last. The ones that are really important are the O and the I because they give me the middle term. So what I do is I make a cute little smiley face. I connect the outers and the inners. You guys see it?
Yeah.
2 eyes, a nose, and a mouth?
Oh.
All right, you connect them and you multiply the numbers. What's 1 times x? 1x. What's 6 times x? 6x. Add them together. 7x. Is that my middle term? So I'm right. I've checked it really, really quickly. Now these are the easy ones. But on the hard ones, this really, really helps. I'm going to show you that in a second, okay? So I want everybody to look at number 4. Let's look at number 4. X squared minus 11x plus 28. Okay? All right, it's a trinomial. Does it have a GCF? Is there a GCF?
No.
No. Okay, so we're going to factor it to 2 binomials. So Will, can you tell me the factors that we know of 28?
1 and 28.
1 and 28.
14 and 2.
2 and 14.
3 and 7.
3 and 8.
3 and 8.
And then 4 and
3 and 8 gives you 24.
4 and 7 and 4, right?
3 and 8 is 24.
You're right. I made a mistake. Sorry. And 7 and 4 is right. Okay. Thank you. All right. Now, which one of those add to 11? 7 and 4. So I've got a 7 and a 4. I've got an x and an x. In order for them to add to a negative 11,
To make them both negative.
they both have to be negative. If I wasn't quite sure, I could go ahead and make my little smiley face. I can multiply the 7 and the x and the negative 7 and the x, the negative 4 and the x. I could add them right here. Do they give me my middle term? And do I know that negative 7 times negative 4 does indeed give me 28? So I can actually kind of do it very quickly in my head and check myself. Does that make sense? All right, I want everybody to try then number 5. Number 5. What do you have to do first? You have to take out the GCF. Good. So everybody should be working on number 5.
Can you do it without taking out the GCF?
You won't have it in its lowest form if you do it like that.
Yeah, but
I always want you to take out the GCF first. No, because 2x minus 6 is not in its lowest form. It's not completely factored. You want to take the GCF out first, Jesse, okay? GCF. I call it GCF in it. Okay? It's legal. I'm allowed to say that. GCF in it. All right, we take out the GCF. The GCF is?
2.
2. So following, what am I left with? Minus 21. Okay. Then we keep the 2 because it's part of the problem. We're going to be factoring to 2 binomials. We need our factors of negative 21 that will add to 4. 7 and 3. Okay, so we look at 7 and 3. So I've got 7, 3, x, and x. Okay, but we want them to add to a negative 4. So that means it has to be negative 7 and positive 3, correct?
yeah.
So x minus 7 plus 3. If I'm not sure, I can make my smiley face and just make sure I put the positive negative in the right place. So you get negative 4x. Okay? All right, we've checked it, so then my answer in factored form is this. Jesse said, what if you don't take out the GCF? If you don't take out the GCF, I want to make sure we understand what you would have gotten would have been 2x minus 6, x minus 7. If you didn't factor out the GCF, that's what you would have gotten. And there is a problem there because this has a GCF, so it's not in its lowest form, and it can be factored more. So I'm always just go through the checklist GCF first. And I know your teacher taught it to you like that. Okay? All right, let's go to the back page. What about when the leading coefficient is greater than 1? Okay? This is where Mr. Smiley Face can be our really good friend. Okay? So look at the first one. 2x squared minus 11x minus 6. The problem now is that I've got the outers and the inners that are being multiplied every single time. So what I do is I look at what are my factors of 2, and they are 2 and 1. Because I have a coefficient here, and I don't have a GCF that I can pull out. Then I look at my factors of 6. My factors of 6 are 1 and 6, and 2 and 3. Everybody agree?
Yep.
Okay. So the first term is easy because there's only one set of factors for me to work with, 2x and x. Okay? But the question is, now I've got this 3 and this 2 and the 6 and the 1, and I'm going to have to multiply to the 2 and the x to get my inner term. So what I do is I actually build my smiley face into the problem. You'll notice after a couple of times it really helps. And then I have to decide which numbers I'm going to use. Well, if I use 2 and 3, I put the 3 here. I'll have a 6 on the outside and a 2 on the inside, which would only give me 8, right?
Yes.
So then I can't use 3 and 2. It's not going to work. So then I try 6 and 1. If I put the 6 here and the 1 here, I get 12x on the outside and 1x on the inside. How can I get those to add to negative 11x?
Plus 1 minus 6.
I make the 12 would have to be negative, the 1 would have to be positive. So for me to get the 12 to be negative, it would have to go there. And you've checked yourself as you've done the problem. So now you know you're right. Do you guys remember doing all this? Mm-hmm. Okay, so let's do some harder ones. 3x squared plus 2x minus 8. First step is do what? See if there's a?
GCF.
See if there's a GCF. Good. So there is not a GCF, so I go through my factoring. I look for my factors of 3 and 1, and my factors of 8, which are 4 and 2 and 8 and 1. Guys, some of the factors, this is just a little hint, it doesn't always work this way. I tend to pick the ones, if there's lots of factors, the ones that are you most commonly see. Like, if I gave you like 24, okay? I would say you probably use 6 and 4 more than 2 and 12. So I tend to go with the most common factors first. All right, so my first factors have to be 3 and 1, because those are my only options. Then, this is just the way I do it. I make my smiley face for myself so I can kind of see. It helps me to see where the numbers belong. And then I go to the most common numbers first. So I go to 4 and 2. Because 4 and 2 are more commonly seen than 8 and 1 when we multiply to get 8. All right, so I'm thinking, if I put the 4 here and the 2 here, and I try it, I guess and check. I get a 6 on the outside, so 6x, a 4 on the inside. Is there a way that I can get them to add to 2x?
Negative 3, positive 4.
Negative 6.
No, negative 6, positive 4 would give me negative 2. So it needs to be positive 6, negative 4. That would give me a positive 2x. So to get the 4 to be negative, it means negative, positive. Do you see why I do that? It's just a little trick to help you when they get harder like this. All right, so then my factors are 3x minus 4 and x plus 2. All right, let's keep going. Harder. 9x squared, I'm going to number 4. 9x squared minus 12x plus 4. Okay, Colin, what do I do first?
You make parentheses.
Okay.
You put 3x minus 2.
Well, you got to factor first. So what do you do first? You need your factors of 9, don't you? What are the factors of 9? 9 and 1 and 3 and 3. How do you know it's 3 and 3? You don't know that, do you? Because there's going to be times that it's 9 and 1. And there's going to be times that it's 3 and 3. Fallon said she wanted to use 3 and 3. So 3x and 3x. Then you got your factors of 4, which are what?
2 and 2 are
2 and 2 and 4 and 1. Okay, I tend to use the more common numbers. Which ones are the more common numbers? 2 and 2. So those are just happen to be the ones I always go to first. So I'm going to put 2 and 2. And then I get this and this. And I get 6x and 6x. And I need them to be a negative 12x. Can I get those to be a negative 12x?
Yeah, you just put negatives.
Negatives. And there's one of the patterns to factoring that always comes up. If this is negative and this is positive, then both of your binomials need to be negative. Okay, and is this coming back to everybody?
Yep.
Yes?
Indeed.
All right, let's do another one. Let's do, all right, 6x squared plus 13x plus 2. Everybody try it. Go ahead and try it. Number 5, 6x squared plus 13x plus 2. All right. Try it. I'm right here.
You have to phone thing. You can't phone them.
There's no GCA.
But how do you do it when
Okay, so that's when you have to come up with your factors.
you oh, never mind.
All right, so what are my factors of 6 that I could use?
1 and 6, 3 and 2.
1 and 6, 3 and 2. Which ones did they work out to be?
6 and
6 and 1. My factors of 2 are 2 and 1. I look at it for myself. Where does the 2 need to go?
The right one.
On the right side.
On the right side.
Wait, it matters.
It does matter because my inner term then would be 1x. My outer term would be 12x. When I add them, I get 13x, so I know I've done it right. Since these are both positive, these are both positive.
Yes.
Yes.
Okay? You got it, guys? I'm not sitting up here reviewing this just to thinking that you know it. You have to know this for this chapter. The entire chapter involves factoring. It's not about factoring, but it involves factoring. We're going to graph with factoring. We're going to complete the square with factoring. We're going to do all this stuff with quadratics and factoring. So you got to be able to do this. All right, one more. One more. And then I'll do some grouping since we're there. 8x squared minus 10x minus 10x plus 3. Everybody get this one. Last one, number 6. Right here. So nice.
This is like a sleep scene.
Both of you, you too, that side of the room. Must be that. All right, who's got this one for me? All right, Zach. What did it factor to?
2x minus 1 and then 4x minus 3.
Let's see if he's right. Negative 6x, negative 4x does give me negative 10x. Negative 1 times negative 3 is positive 3, so he's right. Did we all get that?
Yes.
Yes? Yes?
Yes.
All right, so let's look at some grouping, okay? The bottom of the page, I'm gonna just start grouping, just to get us going, okay?
But there was another way.
Yeah, there's another way you do it.
You could do it so you got negative 12 and then added 2x.
Wait a second.
You could do,
Because I did 4x minus, 4x plus 1 and 2x minus 3.
All right, let's see if that's, maybe we did something
no,
wrong.
I did 4x plus 2.
No, they're both right.
4x minus 1, 2x minus
No,
3.
4x plus 2, x minus 3.
There shouldn't be two ways you could do factoring.
Wait, how
There should never be two ways.
How can it?
Oh, because you can take the 2 out of that.
2 and 3 is not 6, is
Yeah, it's not
is
It's
6,
not plus and minus, it has to be 2 minus.
right? So that doesn't work, so that one's wrong. What else? What did you do, Benny?
I did 4x plus 1, x minus 3.
4x plus 1, x minus 3. Okay, that's not gonna work because
We're going to be positive.
That doesn't equal 10.
It's not plus
Oh,
or
yeah,
minus.
yeah,
these can't be positive.
Yeah, exactly.
2x minus 3.
Okay, so you gotta be really careful. You gotta be careful. If this is positive, this is negative, they both have to be negative. Okay? Absolutely. It has to work like that every time. This one's right. Okay?
I have a little trick to know the signs.
How?
The minus, if a bad guy leaves a good town, it's a good thing. So, because the negative sign's a minus.
Wait,
And if a good guy leaves the town, it's a